Hello my dear students. In the previous video we have seen what is division algorithm and how to verify division algorithm. In today's session we are going to see how to use this division algorithm for finding the zeros of a cubic polynomial or a biquadratic polynomial. Once again I welcome you all to your own channel Novel Mathematics. We'll find a way or make one. Look at the first question. Find all zeros of polynomial f of x is equal to 2x raised to 4 minus 2x cube minus 7x square plus 3x plus 6 if two zeros are root 3 by 2 and minus root 3 by 2. Here you are given a biquadratic polynomial. You know that for a biquadratic polynomial there can be 4 zeros and hence it can be factorized into 4 linear factors. Of the 4 zeros, we are given 2 zeros and we have to find the remaining 2 zeros. The given polynomial is given f of x is equal to 2x raised to 4 minus 2x cube minus 7x square plus 3x plus 6. According to question, x is equal to root of 3 by 2 and x is equal to minus root of 3 by 2 are the two zeros. So here we are given the polynomial and two of its zeros. If two zeros are given, from the two zeros we can write the two linear factors like this. If x is equal to root of 3 by 2 is a 0, then definitely x minus root of 3 by 2 is a factor, and if x is equal to minus root of 3 by 2 is a 0, then x plus root of 3 by 2 is a factor. If x is equal to root of 3 by 2, then x minus root of 3 by 2 is a factor, and if x is equal to minus root of 3 by 2 is a 0, then x plus root of 3 by 2 is a factor. If these two are the factors, then their product also will be a factor of the polynomial f of x. Therefore, we can say that x minus root of 3 by 2 into x plus root of 3 by 2 is a factor of f of x. For example, 2 is a factor of 12, 3 is also a factor of 12. So what about 2 into 3? 2 into 3, 6 is also a factor of 12, no doubt. In the same way, x minus root of 3 by 2 and x plus root of 3 by 2 are the factors. Therefore, x minus root of 3 by 2 into x plus root of 3 by 2 is a factor of f of x. Now we have to multiply these two. To multiply these two is very easy because this is in the form of a minus b into a plus b, which is a square minus b square. In place of a we have x and in place of b we have root 3 by 2. So it gives x square minus root 3 by 2 the whole square is a factor. Square of x means x square minus square root of 3 by 2 the whole square is 3 by 2 is a factor. Taking the LCM, 2x square minus 3 whole divided by 2 is a factor. That means 1 by 2, this whole divided by 2, I can be written as 1 by 2 into 2x square minus 3 is a factor. If 1 by 2 into 2x square minus 3 is a factor, then definitely we can say 2x square minus 3 is a factor. I will explain to you. 6 is a factor of 12. 6 means 2 into 3 is a factor of 12. If 2 into 3 is a factor of 12, then definitely we can say that 3 is a factor of 12. Similarly, 1 by 2 into 2x square minus 3 is a factor. Then 2x square minus 3 is also a factor of f of x. Here, from two zeros, we got two factors and we multiplied the two factors to get one factor, and finally we are getting 2x square minus 3 is a factor of f of x. 2x square minus 3 is a quadratic polynomial. If this is a factor of f of x, and if you divide f of x by 2x square minus 3, the remainder will be 0, and you will get a quotient that will be a quadratic polynomial, because the degree of the dividend is 4 and the divisor is 2, so the degree of the quotient will be 4 minus 2, that is 2. Therefore, we can say that the quotient polynomial will be a quadratic polynomial. The next step is to divide the f of x, that is polynomial f of x, by 2x square minus 3. Here, I am going to show the division procedure. Already I have explained how to divide a given polynomial by another polynomial while explaining the division algorithm. Here the first term is 2x raised to 4, and here the first term is 2x square. 2x raised to 4 by 2x square is x square. Now we will multiply x square with each term of divisor and will write under the respective terms in the dividend. X square into 2x square, 2x raised to 4. X square into minus 3x square, so that we will write under x square term. X square into minus 3 is minus 3x square, that I write under 7x square. Here we don't have a x cube term, so I write it as 0. The next is subtraction. Minus, plus. You know that 2x raised to 4 minus 2x raised to 4 will be 0. Here minus 2x cube minus 0, that is minus 2x cube. Minus 7 plus 3, that is minus 4x square, plus 3x plus 6. Now the first term is minus 2x cube by 2x square, minus plus minus, 2 by 2 get cancelled, x cube by x square you get x. Minus 2x cube by 2x square is minus x. Now we will multiply minus x with each term. Minus x into 2x square is minus 2x cube. Minus x into minus 3 is plus 3x. Here I write under 3x term, and here it is vacant, so I put 0. Now subtracting by changing the sign. Minus 2x cube will get cancelled. Minus 4x square minus 0 is minus 4x square, and 3x minus 3x will be cancelled, and here we get we have a plus 6. Here we have a plus 6. Now the first term is minus 4x square by 2x square. Minus 4 by 2 is minus 2, and x square by x square get cancelled. Minus 2 into minus 2, minus 4x square. Minus 2 into minus 3, that is plus 6. So here we can see minus 4x square plus 6 plus 6. On subtracting, definitely we get the remainder 0. So what is the quotient here? X square minus x minus 2. Here q of x is equal to x square minus x minus 2. Now this quadratic polynomial is to be factorized by splitting the middle term, and as a result we will get the two factors. From the two factors we will get the remaining two zeros. Now I am going to factorize this by splitting the middle term. It's equal to x square minus 2x plus x minus 2. Minus 2x plus x is minus x. Minus 2 into plus 1 is minus 2. Grouping the first two and the last two, I am taking x into x minus 2 plus 1 into x minus 2. Grouping first two terms and the last two terms, I get x common from the first two terms and 1 common from the last two terms. Now we have a x minus 2 common in both the terms, and x plus 1 is left. So the two factors are x minus 2 and x plus 1. That is, x minus 2 and x plus 1 are the factors of f of x. If x minus 2 and x plus 1 are the factors, therefore we can say that x is equal to 2 and x is equal to minus 1 are the zeros of f of x. Here you can see from the zeros we write the factors, and here from the factors we write the zeros. So the two zeros were given and we got the remaining two zeros. Therefore finally we write four zeros are root of 3 by 2 minus root of 3 by 2, 2 and minus 1. This is how to find the remaining two zeros of a biquadratic polynomial when two of the zeros are given. So whenever you are given a biquadratic polynomial, you will be given two zeros and you will have to find the remaining two zeros. In case of a cubic polynomial, you may be given one zero or one factor, and you will have to find the remaining two zeros by the same procedure. Look at today's second question. Given root 2 is a zero of the cubic polynomial, f of x is equal to 6x cube plus root 2x square minus 10x minus 4 root 2. Find its other two zeros. Here you are given a cubic polynomial. A cubic polynomial can have at most 3 zeros. Of the 3 zeros, you are given 1 zero. Here also we have to find the remaining two zeros. Given f of x is equal to 6x cube plus root 2x square minus 10x minus 4 root 2. According to question, x is equal to root 2 is a zero of f of x. We are given 1 0. From this 0, we can write one factor of f of x, that gives x minus root 2 is a factor of f of x. A cubic polynomial can have at most 3 zeros, hence it can be factorized into 3 linear factors. Of the 3 factors, we have one factor. If you divide this polynomial f of x by this factor, we will get the remainder 0 and the quotient will be a quadratic polynomial. The next step is to divide f of x by x minus root 2. The division procedure already you know. 6x cube plus root 2x square minus 10x minus 4 root 2 divided by x minus root 2. First term by first term. 6x cube by x is 6x square. 6x square into x, 6x cube. 6x square into minus root 2, that is minus 6 root 2 x square. 6x square into x, 6x cube. 6x square into minus 6 root 2 x square. The next is subtraction by changing the sign. 6x cube minus 6x cube will be cancelled. Root 2x square plus 6 root 2. Root 2x square plus 6 root 2 is just like root 2 plus 6 root 2. Root 2 plus 6 root 2 is just like y plus 6y. What is y plus 6y? 7y. So here it becomes 7 root 2 x square minus 10x minus 4 root 2. Now the first term is 7 root 2 x square by x. 7 root 2 x square by x, you will get plus 7 root 2 x. 7 root 2 x into x is 7 root 2 x square. 7 root 2 x into minus root 2. Just multiply these two. 7 root 2 into minus root 2. Plus minus will be minus. Root 2 into root 2, 2 into 7, that is 14x. Now subtracting by changing the sign. 7 root 2 x square minus 7 root 2 x square will be cancelled. 10x plus 14x is 4x. Then minus 4 root 2. 4x by x is plus 4. 4 into x, 4x. 4 into minus root 2, minus 4 root 2. So you can see the remainder will be 0. Here the quotient polynomial is six x square plus 7 root 2x plus 4. This quadratic polynomial can be factorized into two linear polynomial. To factorize, we need two numbers whose product is 6 into 4, 24, and whose sum is 7 root 2. On multiplying, we should get a 24, and on adding, we should get a 7 root 2. That is, 7 root 2 is to be splitted in such a way that on multiplying, you should get 24, and on adding, you should get a 7 root 2. They are 4 root 2 and 3 root 2. Look at 4 root 2 plus 3 root 2. 4 root 2 plus 3 root 2 is 7 root 2. On multiplying, what do you get? 4 into 3, 12 into root 2 into root 2, 2. 12 into 2, we are getting 24. So, the middle term of this quadratic polynomial can be split as 4 root 2x plus 3 root 2x. So it becomes 6x square plus 4 root 2x plus 3 root 2x plus 4. On grouping the first two terms and the last two terms, from the first group, that is from the first and second term, we can take 2x common. After taking 2x common, we have a 3x plus 2 root 2 inside the bracket. From the last two terms, we can take root 2 common. After taking root 2 common, we will have 3x plus 2 root 2. You can verify 2x into 3x, 6x square. 2x into 2 root 2, 2 into 2, 4 root 2x plus root 2 into 3, 3 root 2x plus root 2 into root 2, 2, 2 into 2, we get 4 back. Now we have 3x plus 2 root 2 common. If I take 3x plus 2 root 2 common, then we will have 2x plus root 2 inside the bracket. So we have factorized this quotient polynomial, which is a quadratic polynomial, into two linear factors. That is, we can write 3x plus 2 root 2 and 2x plus root 2 are the factors of f of x. If these two are the factors, then we can write the two zeros. Therefore, we can say that x is equal to, plus will be taken as minus 2 root 2 by 3, and here also x is equal to minus root 2 by 2 are the zeros of f of x. So we are given a cubic polynomial and 1 0. From 1 0 we got one factor. By using that we got the remaining two zeros. Therefore, the three zeros of f of x are root 2 is first given, then second one is minus 2 root 2 by 3, and third minus root 2 by 2. This is how we got all the three zeros of the cubic polynomial. My dear students, we have done two questions based on the division algorithm, one for a cubic polynomial and other for a biquadratic polynomial. With these two questions, I hope you understood how to solve these kind of questions. If you have any doubt about any question, put the question as a comment in the comment box. Definitely I will be making videos for those questions also. That is all for today. Have a nice day. Take care.